Hello, my name is Colin Crowley. This is my video presentation for the final project. The topic that I chose was stereo correspondence. So these are all of the files that I'm submitting. So here is my report with all of my results and analysis. I set up my code files similarly to the problem sets. So all of my implementations are in this file, final.py. And then in experiment.py, I have several parts that sort of test each of the methods with different images. And then, like with the problem sets at the bottom here, you can comment out different parts or run them all together or what have you. In the README, I explained that I use Pimax Flow, so that needs to be installed, as well as its dependency Cython, and then to run the experiment.py to run the code the same way that I did. Here at the bottom, I've outlined how long it took on my machine for each part to run and how many images to expect to be output. So it's important to have these input and output folders, just like with the problem sets. These are all of the images that need to be in the input folder in order for the experiment.py file to run correctly. And then this is the output directory also needs to exist, and these are all of the output files, which I'm also submitting. But you can obviously run my code to verify that they are generated correctly, keeping in mind that the last part takes about 50 minutes to generate the images. In my report, before I dive into each of the algorithms, I talk a little bit about just some housekeeping things to know for how I attempted or how I tackled the project. One thing that I created a test bed, so just like a simple pair of images to verify that my algorithms were working as expected. I also talk about how I take the disparity map and visualize it, which basically just normalize it into the range of 0 to 255 and then use a false color map. And then occluded pixels are colored black, which the part 2's algorithm has support for occluded pixels. These are the two images that the two real images that I use to test my algorithms. Both of them come from the Middlebury datasets. And then these two images right here are the ground truth disparity maps, which I visualize the same way that I visualized my disparity maps, but these ones are the ground truth ones that come from Middlebury.